Hi, it's Lynn again. Today is more radicals. We're going to be adding, subtracting, and multiplying radicals. We already did dividing radicals if you've seen the other video. So one of the hints for adding is that you can only add like terms. So for instance, square root of 2 acts like an x. So for instance, if I have 3 times the square root of 2 plus 4 times the square root of 2, that would be the same as if I had 3x plus 4x. Well, 3x plus 4x is 7x. So 3 root 2 plus 4 root 2 would be 7 root 2. So the root 2's stay the same, just like the x's stay the same when you're adding. So let's keep that in mind when we do this example. And we look at these, we go, wait a second, nothing's the same. I can't add anything. Well, if you remember, what we need to do is simplify each of these to see if in their simplified form they have the radical part or like the variable part that matches, so then you can add the coefficients. So we look at 27, and 27 is 9 times 3. So we have 9 times 3 times x, and it's a square root, so the 9 comes out as a 3. So we have 3 times the square root of 3x for this one. This 9 will come out as a 3 and multiply that 2. So this is going to be minus 6 square root x. And this one, the 36 can come out, so that's plus a 6 square root x. And notice that the root 3x and a root x are not the same kind of thing, because we have to look at what's underneath the radical. So this has no like terms with it, so we can just leave it as 3 times the square root of 3x. And then what we do here is we add the coefficients. The root x will stay the same, and we have a minus root x and a plus root x, so they just cancel out and make each other 0. So our final answer is just 3 root 3x. So that's the adding example. All right. So here's another example with subtraction. Notice that these are not like radicals, just like in addition. So we're going to apply the quotient rule, and so we can go, this is the cube root of 6y divided by the cube root of 64 minus 3 times the cube root of 6y. Cube root of 64, 4 times 4 times 4, so there's 3/4 is 4. So this one just turns into a 4. And you're like, oh good, well look, the radical parts are the same. Cube root of 6y, cube root of 6y. I'm going to write this, it's a little more clear. Cube root of 6y. The problem is these don't have a common denominator. So we need to get the common denominator of 4. Since this is an expression, not an equation, we can't clear it. So we multiply a 4 on the bottom and then times 4 on the top. So this will be, our common denominator will be 4. And this will be, and there's an invisible 1 in front of here. So 1 cube root 6y minus 12 cube root 6y will equal negative 11 cube root 6y divided by 4. So that's a subtraction example. All right, here we are with the last part, which is multiplication. So this is our first example. This is one term times two terms, and we can just use the regular distributive property, but we need to be careful with the radicals. So this is root 5 times 2. Root 5 is in jail. The 2 is outside of jail, so that's just going to be the coefficient. They can't talk to each other. The 2 can't go in jail, and the 5 can't come out of jail unless it has a partner. So this will be 2 times the square root of 5, and then it would be plus, and root 5 times root 15, they're both in the same kind of radical or the same kind of jail. So I'm going to write this as 5 times 15 because they can go in the same kind of radical. Now we have to see, well, can we simplify this? Well, we know that 15 is 5 times 3. So just to save room here, I'm going to write this as 5 times 3. And hopefully at this point you notice like, oh, look, there's a pair of 5s. They can escape from jail. So we have 2 root 5 plus 5 root 3, because the 5 comes out and makes a 5 out there. Then we say, okay, can we simplify this anymore? A root 5 is different than a root 3, so we're done. So that's our final answer for this one. This one is a little bit more complicated because now we have 2 terms and 2 terms, and what we have to do is FOIL. So FOIL is first, outside, inside, last. So the first is root 2 times root 6. So I'm just going to write that under one radical because they're the same kind of radical. So root 2 times 6. The outside is root 2 times 2. The 2 is outside of jail. This 2 is inside of jail, so it's plus 2 root 2. The inside is minus root 5 times 6. And then this is minus 2 root 5. Ran out of room there a little bit, but I think you can probably see this. Now our test is to see how we can simplify this. So this is 2 times, and the 6 is 2 times 3. So this 2 can come out. So this is a 2 times the square root of 3 for this one. This is 2 times the square root of 2. This one is 5 times 6, which is 30. So minus square root of 5 times 2 times 3. There's no pairs, so I can just make that 30. And then minus 2 root 5. And notice that we don't have anything here that can combine, so we just leave it like this as our final answer. Now this is a little bit tricky. The most common mistake with this one is that people just want to square the 1 and then square the 2 root 3. But whenever we have a quantity squared, it's a FOIL problem. So I'm going to rewrite this as 1 minus 2 root 3 and 1 minus 2 root 3. I would recommend that as a tip. When you see a quantity squared, rewrite it as itself twice. So now we're going to do FOIL with this one. 1 times 1 is 1. 1 times minus 2 root 3 is minus 2 root 3. The inside is minus 2 root 3. And the last would be positive, and the 2 times 2 multiplies as a 4. Root 3 times root 3 will be root 9, which is, and I can just write that as 3. So 4 times 3, that's just going to be 12. So it's going to be 1 plus 12, which is 13. And these are like terms because they're both root 3s. So it's minus 4 root 3. That's a final answer for that one. So there's just the regular distributing, there's FOILing, and then there's a squaring, which you have to turn into FOILing. So be careful when they're this same kind of radical, you can put them together under one radical. Always make sure you're simplifying and taking everything out of the radical that you can take out. So there's the 3: adding, subtracting, and multiplying. We've gone over them all. Have fun.